Hey everybody, welcome back. We are going to look at another example of hypothesis tests in this video. Go in step by step. So we're told in this problem, drug testing of job applicants is becoming increasingly common. The Associated Press reported 12.2% of those tested in a California sample tested positive. Suppose this figure had been based on a random sample of size 600. Does the sample support a claim that more than 10% of applicants in California test positive for drug use? Test the 1% significance level. So we're pretty clearly asked, right? Does it support a claim that more than 10% of job applicants? It doesn't say to test it, but it asks, does this support this claim, right? When we want to try to support a claim that about a population proportion, right? So the population here is all job applicants in California. And we can tell this is a proportion, right? It just clearly asks more than 10%. We're given this sample size of 12.2%. And the context of the question, right, is a categorical variable. Do you test positive for drug use? Yes or no? So here in step one, we've determined, right, when we write out our null versus our alternate hypothesis, we've determined that this is a test about a population proportion. We're going to fill out HA first, and we're asked if this supports a claim that more than 10% of applicants test positive, right? So that more than tells us that we need to use the greater than sign, and we're going to write this in terms of a decimal instead of a percentage. So is it greater than, is it more than 10% or 0.10? Is the proportion of all Californians, right, who do a drug test, right, for jobs, do more than 10% of all of those people test positive for drug use. And remember, we always put the equal sign in our null hypothesis, and we put the same proportion or average, right? If we're doing an average problem, we put the same number, the same value of interest in our null hypothesis. So remember, we're asked in the problem if this supports the claim that more than 10%, blah, blah, blah. This is the thing that we're trying to show. This is what we're being asked to show. This is what we put in our alternate hypothesis. This is the thing we're trying to prove or show or support. And the null hypothesis is what we're going to try to reject. So in step two, we simply state our level of significance or our alpha value. And we're told to state the test with a significance level of 1%. We're not told that that is alpha, right? So we need to know that alpha is the significance level itself. I'm just going to be lazy here and write 3 for step 3. This is where we write out our statistics, right? So for a proportion, we just have 2 statistics. We have our sample size. We're told here based on a random sample of size 600, right? Pretty straightforward. And we were given that that sample proportion, the Associated Press reported 12.2% in a sample. Sorry about that. was 12.2%, right? So I'm going to, again, write this in the decimal format instead of the percentage. So 12.2, just move that decimal place over twice and it's 0.122. Step 4, we need to calculate our z-score, right? Because the proportions are normally distributed, right? So we take our sample proportion, we subtract that from the null hypothesis population proportion. And then in the denominator, we also use the null hypothesis proportion, right? 0.10 times 1 minus 0.10. And we divide by our sample size of 600. We take the square root of that. So this difference up top should be 0.022. If you take 0.122 minus 0.1, yep, 0.022. Lost my mouse. Still lost it. Okay. And then if we take 0.1, 1 minus 0.1 is 0.9, right? So 0.1 times 0.9 is 0.09, right? So I'll just draw this out, 0.90, right? This is that 1 minus 0.1. Still have to divide it by 600 and take the square root. So we still have our 0.022 up top. 0.1 times 0.9 is just 0.09. Divide that by 600 and take the square root. You get 0.022. 0.09 divided by 600 is a very small number. 0.000115. Then we have to take the square root of that, right? So we're just carrying this 0.022 all the way through. The square root of 0.00015 is 0.0122. So now finally, if we divide 0.022 by this 0.0122, we get a z-score of 1.80. Okay, so that was part A of step 4. Part B is to draw our picture, determine if we want the area under the curve to the left or the right of the z-score that we found, right? So 1.80 somewhere in between 1 standard deviation, 2 standard deviations away from our mean. Just to remind you, because this is a z-score, this picture that we're drawing is a standard normal curve, right? So it has a mean of 0, a population standard deviation of 1. So as we go 1 standard deviation away, we're at 1, 2, and then 3 standard deviations away, we're at a value of 3. So pause here. See if you can determine if we want the area under the curve to the right of 1.8 or to the left, or do we want 2 tails, right? So do we need the negative 1.8 down here, the area underneath that, and the area above 1.8? Pause here, see if you can figure it out. To determine this, we need to look at our alternate hypothesis, and specifically the inequality in that alternate hypothesis, right? Which came from our question. Remember, we have nicknames for this. If you use a greater than sign, the nickname for this test is a right-tailed test. So think greater than, you want everything under the curve greater than 1.8, right? Or, that nickname is right-tailed, so you need the area under the curve to the right of your z value, your cutoff value, which is the right tail of it. So just a reminder, this unfortunately is going to disappear when I stop sharing. I wonder if I can save this. Let's say, try to save it as a PDF. Oop. Okay, so now we take this 1.80, we need to find the area under the curve, right? In step B as well, to find our p-value, right? So we can use our handy dandy calculator. If I can find the screen. Let me try 1 second. Okay. Looks like I got kicked out. Starting up my calculator on my computer. Give me 1 second. Okay. So now I will pull that up. All right, so we have our z-score. We can go to second vars, take us to the distribution. This is a normal distribution, right? So we use option 2, the normal CDF. Now our lower value, right, because we want the area under the curve to the right of 1.8. 1.8 is going to be our lower cutoff. We want everything to the right all the way up to positive infinity. So to write out positive infinity, we type in 1, hit that second button, then the comma button to get an E, right? And we write 99. This is how our calculator reads positive infinity. And again, as we just talked about, this is a z-score, right? So we're talking about a standard normal distribution, which has a population mean of 0 and a population standard deviation of 1. Hit enter, and we get the area under the curve to the right is 0.036, we'll call it. That's our p-value. Let me see if I can find that. PDF that was supposedly downloaded. If not, I apologize. Me. Yeah, I'm not seeing it. Okay, so I'm gonna pull this back up for problem at hand. So you should have it written down in your notes. But step 4B, right? Calculated our p-value. Was equal to 0.036. So now in step 5, we compare our p-value of 0.036 to our alpha value, which is equal to 0.01. And our p-value is actually greater than our alpha of 0.01, right? Remember alpha, we stated this in step 2. We were told to test with a significance level of 1% or 0.01. Our 0.036 that we calculated is greater than this. So now in step 6, we fail to reject we go back here, step 6, we say that we have to fail to reject HO. We say there is not significant evidence to suggest HA, which was more than 10% of job applicants in California test positive for drug use. Okay. So this would be our conclusion. We failed to reject HO because our p-value is greater than our alpha. Note that if the problem told us to test with a significance level at 5%, if alpha became 0.05, then our p-value would in fact be less than that. And that would totally change the conclusion, right, in our step 6. If that were the case, if alpha had been 0.05, we would reject HO. And say there is significant evidence to suggest HA. But we had 1%, got this result, so we failed to reject, and there is not significant evidence. All right, next time we'll look at an example for a population mean.